Thank you for the warm welcome, Nisha. Thank you to the very warm welcome from the community here. I see all the hands, so much love to everyone. Thank you for the welcome. Yeah, super excited to be here today. I'm a product manager on Google Cloud's Vertex platform, focused on search, agents, grounding, everything to do with helping get your agents up and running and connecting them to the data they need to be successful. So very excited to be here at today's session. Let me take over presenting mode, if that's okay, Nisha. I'll present now. Okay, I think you can all see my screen. So yeah, so today's topic, agent grounding, using the Vertex developer platform to connect to enterprise, web, and maps data. And this is a very topical session. Just in the past couple weeks, there's been a lot of change in this space. I mean, I guess no surprise given the pace at which the industry is moving. But even putting together content for a seminar like this, it's incredible how much need there is to capture kind of the latest snapshot of where we are. So very exciting to get to cover this. I figured I'd start out by just kind of establishing the foundation of how we think about an AI agent at this point and where this kind of subject matter intersects with agents. And I think this is a fairly reasonable representation of an AI agent today. So you've got your model, which provides a lot of the reasoning, thinking through the goals and coming up with a plan and an answer. You've got access to tools that model can call on to perform some action. These could be APIs, data. There's an orchestration piece, connecting the agent with the data or potentially with other agents, as well as things like memory, both short and long term. So remembering what's happened in the session with the user itself, as well as longer term, what's happened in previous sessions with those users. And then the actual runtime there itself, which is where how the system is maintained and executed. And I think with all of that packaging, you can see that little note there in the bottom, which is RAG and grounding, the connection to the data piece is actually a really critical part of that tools portfolio. And so this is making sure that agent has access to all the relevant, fresh data it needs to successfully deliver an accurate outcome to its users. And so what does this end up actually meaning in practice? So when you think about connecting your agent to additional sources of data, well, a big part of this is the accuracy of the response. Obviously, if it doesn't have access to the right underlying data to answer a user's query or need, there's a risk of traditionally it's a risk of hallucinations. So we would just really want to make sure that agent is grounded in the right information. A big part of this is enterprise data. Obviously, agents and models themselves don't have native access to enterprise data, so making sure that foundation is there. Similarly, depending on when a model was trained, the day after it's trained, it will no longer have access to the latest fresh information, and so we want to make sure it's connected to whatever world information is needed to help answer user queries. Traceability is a big thing for obviously developers. So for those in the community who are thinking about how do I actually understand why my agents are performing the way they are, having that kind of trace, that kind of visibility into the information that's provided to the agent, how it's using that information is really critical. And then be able to tailor all of this to the specific needs of the user, depending on their query, depending on the request. The fun thing about taking a look at this space is just in the past year itself, how much more sophisticated the methods have become for connecting agents to the data they need. And we're seeing a lot of the reasoning being pushed upstream into the models themselves. And so, obviously coming from the Google side, from the Gemini ecosystem, one of the fun things is now users of Gemini get a lot of the benefits of this kind of agentic reasoning out of the box with Gemini. And so you're not even necessarily having to configure a lot of those kind of reasoning boxes that you see around the edge there yourselves. You may do it as part of your own enterprise system, depending on what you're developing. But Gemini itself actually provides a lot of this. So it's developing a more robust understanding of a user's intent with that query transformation piece, actually reasoning through, well, what information do I need to go collect about this? Is it real-time weather information? Is it current events? Is it something else? Planning on how to actually go retrieve that information and doing the retrieval, and then thinking through, do I actually have the information I need now to provide an answer, or do I need to take another pass at this? And again, that being able to run that cycle multiple times is something that 12, 18 months ago would have required some additional development steps, and now you're getting that kind of natively with the models themselves. So really great to see this kind of loop being provided, and you see all the kinds of data sources that frequently pop up. So it's obviously a lot of different enterprise data parts. Web, we'll talk about that, even third-party data and other tools. At a high level, when you think about connecting users and agents and data sources, there's kind of like 3 buckets of information that generally come up the most. So one, again, is this kind of private enterprise data, and we'll kick off with that one. The other one is world information. So we'll talk about, in our case, being able to connect things like Google Search and now Google Maps to your development tools. And then third-party data is another interesting one. So for enterprises that have made kind of significant investments in third-party data systems, whether it's like S&P data or Moody's data, be able to, in the same way that you work with these other data sources, be able to leverage those data investments as well. So let's kick off with enterprise data. Again, if you were to ask most enterprise questions directly to a model that doesn't have access to relevant enterprise information, you're not going to get a helpful answer. So in this case, you see at the bottom, if you ask about a PTO policy, a grounded response is able to go understand, oh, I need to actually go pull the latest PTO information, and I need to personalize the answer as much as possible for this user. So you see you have 15 days of PTO remaining. And that could be a really great outcome, be able to pull that information to reason through what exactly to provide to users. The foundation for a lot of this is embeddings, and I thought I'd just kind of quickly touch on this piece because it really does drive a lot of our ability to deliver relevant information to users. So for the kind of reestablishing this, they're kind of magical in some ways. I think about embeddings, which is being able to capture kind of the essence of the meaning, whether it's the information that we're indexing. So it could be that enterprise content and or the user's query itself, really being able to understand what is the intended meaning of this information and how does it map to each other. And so in this example here, items that have similar meanings are going to be plotted much more closely together than items that have very distinct kinds of meanings. And so you can see in this example, various kinds of dresses are grouped together, and other items that are less relevant are grouped further out in the embedding space. And so this kind of deep semantic meaning, as we refer to it, really drives a lot of our ability to deliver relevant information to users. When we actually think about the process of converting our information to these embeddings and be able to store it and serve it to users, there's a couple different steps that we often talk about. So there's an encoding step, which is using the latest embeddings models to generate embeddings from your data. And there's a selection of models, and we'll talk about some of the options that are out there. There is an indexing piece, which is organizing that kind of vast array of embeddings out there in a way that makes them easily searchable, fast, accurate, such that when a user comes in, and this is the third piece there, at runtime, when a user query comes in, also being able to generate an embedding on it and find the most similar results. And at that point, we're able to deliver results across a number of modalities. Obviously, text is a foundational one, but increasingly we see a lot of use cases around some of those multimodal pieces there as well. So image, audio, and beyond. A lot of this process, I'm sure you've heard of, RAG process at this point, indexing, retrieval, generation. A lot of this is fundamentally search. And so one of the fun things about being Google at this time is like, yeah, there's a lot of actually search technology and search infrastructure that we can apply now to this space and make it hopefully really easy for developers to leverage kind of like the best of Google and what we know around search to help you actually generate really helpful, really great agents. There's a lot of pieces that can potentially go into this pipeline for better and for worse. And so, within the indexing piece, there's connecting to the data that your agent needs. There's preparing that data, so chunking it into pieces, creating the embeddings, storing those embeddings. There's the retrieval piece. So when a user query comes in, likewise being able to understand the user's intent, finding the relevant information, and then ranking and re-ranking it depending on the need. And then there's the actual generation piece. So using the model, whether it's a Google model or a partner model, to actually be able to generate the right response for a user. One of the things that I think is helpful to highlight in this, and this kind of goes back to an architecture that Google's leveraged for over a decade at this point, and I think some developers are familiar with this, and others find this helpful, is that we often think about a two-stage retrieval process here. And so the reality is you may be dealing with kind of millions of potential embeddings out there or parts of the enterprise corpus. When you do that first pass at retrieval, you may only end up with like hundreds of results. And these are hopefully going to be very similar, semantically similar or lexically similar. But we may add an additional ranking piece there to finally get this down to a few key, highly relevant results that the model can then base its response on. And so that ranking step there is worth calling out. And you see the flow here of moving from millions, billions of potential candidate documents down to hundreds and then only a few. And you'll see this flow kind of defines how we on the Vertex developer platform think about this. So you've got our Doc AI solution on the left, which is our tool for being able to prepare data, embeddings models used to generate embeddings, vector search, we'll explore this in a little bit more depth, and then the ranking API itself. So as you saw, the first part of this is taking your enterprise data and actually making it ready to be able to generate embeddings on. And the reality is increasingly that enterprise data includes both structured data, but a lot of unstructured data as well. So think of PDFs, slides, charts, diagrams, text, audio and video as well. How do you actually prepare all of that unstructured data and make it available to an embeddings model to be able to go process for downstream usage? And so our solution from the Vertex side is our Doc AI layout parser. Things to highlight is one, the multimodal nature of the data that increasingly we see being needed. If you take an example on the right there, so that's a typical chart that you'll often find in a slide, for example. Historically, it's been very difficult to process a chart like that and maintain its meaning for later downstream applications. One of the really amazing things now with what we've been able to do with Doc AI, particularly in just the past 12, 24 months, is really seeing much stronger levels of accuracy and understanding of charts like these. So being able to extract not just the numerical data that's there, so for each of those bars, understanding where they are, but also the context of that data. And again, keeping both the quantitative data and the context together, that's a lot of what you're getting out of a document processor, in our case, the Doc AI layout parser. So accuracy is obviously really big. And then that third piece there, you'll see this kind of highlighted as well throughout solutions, is the increasing desire to be able to customize to some extent as needed. So in this case, being able to bring your own schema as you're creating these chunks. The second part in our flow is the need to generate the actual embeddings themselves. And this is a space where the Vertex team has actually been invested a lot in recently, and you can see some of the benchmarks there on the right side. I'd say the themes to keep an eye on here, one is, again, the multimodal nature of these flows. And so moving beyond just very kind of text oriented solutions to solutions that are using images and video as well. And so you'll see from the Vertex embedding models family, you'll see both our text model, which is the Gemini embeddings model, which just came out a couple months ago. The interesting thing about that, it's now converging across languages, so English, multilingual, code as well, as alongside our multimodal embeddings. So one of the interesting things is, like, over time, are we looking at a world where you're converging more and more of these embeddings? Do we end up with just basically a single embeddings model to rule them all? We're not there yet, but certainly if you look at the trend lines, it seems like there is more and more convergence. The other part of this is the efficiency piece. So looking at, when you're working across vast data sets, how do you actually think about, managing cost at scale? And so starting to offer more and more of those efficiency levers here. So you'll see this both across the embeddings models and across tools like vector search, where you do want to balance both performance and scale and cost. And we can talk about some of the levers that come out of this. So vector search is kind of like the foundation for a developer platform like this. Again, connecting your models and agents to the data they need. Historically, on the Vertex side, our vector search is basically using the same technology that Google Play, Search, and YouTube have used, and now in kind of repackaging and offering it for enterprise developers. So it has always shined at the largest use cases there, and you can see some of these hundreds of millions embeddings or 1 billion embeddings. As the scale of the workload grows, really being able to maintain very high levels of accuracy at sub 10 millisecond speeds, and so that's really where vector search has shined over the past few years. And then we've been layering additional kind of features and capabilities on it. So obviously trying to make it easier to use with auto scaling and some framework integrations. Hybrid search has historically been a very frequently requested one. So being able to run both semantic search and keyword search. So for example, if you've got a use case, if it's an e-commerce use case with certain product SKUs or very specific product names where semantic search doesn't make sense, but a keyword search does, being able to run both of those rather than trying to maintain parallel search paths makes it life much easier. This is a space where I'll briefly just double down on some of the ways that we're thinking about how vector databases and search are evolving. And for us on the Vertex side, a lot of the story is, again, trying to make the developer experience cleaner and easier for the community to be able to leverage these tools. So regardless of the size of the application, the size of the team, where you are in your development cycle, be able to quickly get up and running. That's really a big focus for us on the vector search side. So a couple features to highlight that we're now rolling out. This one is actually rolled out is metadata storage. So this is the ability to store arbitrary metadata alongside your embeddings, and this ideally removes the need to maintain a completely secondary data store. For a lot of developers, again, this was a big pain point of having to maintain one data store for embeddings with vector search and then somewhere else the metadata, and now you can combine these together with a single call. Another big option for developers who've made investments in their data architecture using something like BigQuery is being able to leverage the existing data that's in BigQuery and automatically create embeddings based off of that data rather than having to port all the data out of BigQuery. And so at this point, you're able to connect BigQuery and vector search, which really should make indexing and embeddings management much easier. And then the third one to highlight is storage optimized vector search. So this is a new tier backed by SSDs that's intended to be much more cost effective, especially at scale. So if you've got use cases working with really large data sets and potentially requirements are a bit lower in terms of lower traffic, this is a great option. I think, again, the theme you're seeing across all of these is a much easier developer experience. This all comes together for us in kind of a broader reimagining of what vector search should look like. And so on our side, we're rolling out what we call our Vector Search 2.0, which again is really intended to radically simplify what the developer experience is and how quickly you can get started. We don't want vector search to be the hurdle in your agent and Gen AI use case kind of development. We want this to be a tool that you can very quickly use. And I think this is again a common theme, certainly in the Vertex world here in Google Cloud. I think in the industry as well, of continuing to make these solutions easier to use. So I'll just highlight a couple of the ideas and kind of the philosophy that drives our thinking around Vector Search 2.0. So the core of this new experience is what we call a collection. And the idea here is we're moving away from managing separate independent vector indexes and now working directly with this idea of a collection. And it really is intended to be this container, as you can see there, for all your kind of related data objects. So think of your raw data, your embeddings, and still being able to leverage those features like hybrid search, metadata, filtering, all of that. And the idea is like this really does act as a pretty smart, kind of flexible table where you're able to define the schema for that data. And really importantly, the key to this is it ends up unifying both the vectors and embeddings themselves alongside the original payload data. So you're now unifying these in one place. And as you can see with the kind of code snippet there, you're relatively easily able to create a collection, define a few properties like plot and year, and then specify which embedding model to use for that field. And the idea is that the system from that point on handles the rest. So it's a little bit of embeddings creation magic there. And again, the idea is to really be able to accelerate the time to which you're able to get an application running if you're using a tool like vector search. So going from raw data to something that's live and queryable in minutes at this point, hopefully with pretty limited code required. So in this new model, first, you're establishing this new knowledge core, as it were. You're creating a collection. You're defining the schema with the embedding model, and this just generates the embeddings for you. So essentially, you're just saying what embedding model you want, and there you go. The second part of this is populating it with knowledge. So in this example, we're adding just a single movie object there, and the embedding is generated automatically for us. And this obviously is intended to scale to millions of objects in batch, assuming that's the way most developers will work with it. And then the third part of this is the query piece. And so you can immediately query the system for retrieval, using natural language. So again, you don't have to worry about the embeddings or the tuning. You can just start querying. And so, in this example, we're looking for a movie story about hope in prison made after 1990. And so with that relatively simple code and those kind of filters there, you're able to do both a semantic search we've done here, but you could also do a full text search. So offering more levers to developers in this way, and intending to make it very flexible. The reality is, and I think this is one of the interesting trends to highlight, is that this kind of collection is becoming more than just a search index in and of itself. And we're kind of seeing this evolution towards becoming effectively, this is a NoSQL database for your data. So you've got access to your objects at all times. You can retrieve a single object directly by its ID, as you see in the example there, or you can list and filter objects based on other metadata properties. So again, finding movies since 2020. And I think the idea here is this is both much easier to use, but also opens up a lot of use cases beyond just search. So think of e-commerce examples, certainly. And so at the end of the day, this is all intended to bring vector search into this agentic era. And again, with auto embeddings, the embeddings are handled for you. You still got the power of hybrid search across both semantic and keyword search, with optional query rewrite features built in to the feature. So really being able to understand user intent, as mentioned before. And then the semantic ranker is there as well. So you get the benefits of much smarter ranking without the need for a separate API call. So bringing this in, this really is the intended as with the future vision there as well. So making the pipeline even smarter, as it were. So we're working on making this fully programmable, enabling self-improving results, and providing a really easy native A/B testing framework to make sure you're getting improvements that you expect. At the end of the day, this is all about you don't have to choose or manage VMs or shard configurations anymore, which has historically been a huge pain point. You're getting a lot of this kind of auto performance tuning you see as well, and the scaling becomes really easy. So you don't have to worry about resizing your VMs and provisioning them. All that scaling happens under the covers, and you're still getting all the performance that we managed previously. So you get all the benefits of a system like vector search with less of the pain. The final thing I'll highlight here is just the way that we're also thinking through new kind of pricing models to make this easier for developers. So you see there at the bottom a new serverless tier. And so again, the idea is, how do we make it easier for developers to get those prototypes running quickly and potentially supporting use cases with very low or kind of fluctuating traffic, and so moving more towards that traditional serverless pay-per-user experience. But then, as you think about graduating to production, offering dedicated usage tiers. So you just choose whichever tier makes most sense. If you want to optimize for cost and scalability, there's a storage tier. There's a high performance tier as well, just really depending on user needs. And then in terms of the ranking API, so this is the final piece in the puzzle. Again, this is a place where on the Vertex side, I think we made a concerted push over the past 12 months to really improve the quality of our ranking API. And you can see it's now leading once again some of those public benchmarks there. The question I probably get most often is, all right, Greg, so I see that this ranking API adds, helps generate additional accuracy, but what am I paying in terms of latency in particular if I'm adding an additional hop to the solution? And at this point, with the very targeted investments we've made in accelerating the performance of the ranking API, it's like sub 100 milliseconds. So depending on your needs, depending on the solution, this can be a very helpful part to add, and obviously something that Google has leveraged for a long time. I'll quickly just highlight a couple of examples from the real world. So this is one with our friends at AstraZeneca. This is an interesting example. They've got a really interesting data set across video, audio, and these are mostly recordings of interviews done with the scientific community, and trying to accelerate how quickly a researcher can extract the nuggets that are specifically relevant to their research. Historically, this is a very time-consuming process. Think of literally watching every interview that's been done with these specialists and trying to figure out which pieces are relevant. Now, these researchers are able to quickly search using natural language across the entire archive of video and audio interviews and extract the pieces that are relevant to them. So again, really accelerating the rate of scientific research. Another fun one, more from the e-commerce world, is Home Depot. So as any of you know who tried to assemble or first discover which product is right for you and then assemble it, there can always be questions and pain points in terms of figuring out what to buy and how to put it together. And so obviously Home Depot, not surprisingly, this is a large retailer in the US for home improvement. They're very familiar with this pain point, and so have assembled this collection of user reviews and product guides and Q&As, and made it essentially searchable to their community of users that's out there. And so at this point, if you have a question around how to assemble a grill, what connections to look out for, you can find all of that rather than trying to dig through the notes of a product manual that you may or may not still have in your collection. And then finally, with RCS Media Group, so this is one of the leading media companies in Italy. They've got a very mixed archive going 100+ years back across text, so newspaper text, video recordings, audio recordings, and trying to make this available both to their internal users, so think of their editors and writers who are creating new content, as well as to their customers. So be able to search on the website, for example, and find all that great content that historically was not easily accessible. All right, so we've talked about connecting your agents to enterprise data. let's talk about actually connecting it to the latest kind of world information that's out there. And I'll highlight kind of two solutions that have emerged over time. So as a quick example, if you ask a model about the latest sports information or weather information, an ungrounded model obviously doesn't have access to relevant information. But ideally, if you ask a model that's connected to a source like Google Search or Google Maps, you'll get much more accurate, fresh answers. So this is one of the investments that we've made, is being able to make it easy to connect agents to a tool like Google Search. And the idea is, especially with Gemini, we can actually natively understand whether that's a query that requires this kind of fresh world information. Go perform a Google search, return the results, and then you can see from the design there, actually presenting both the results as well as additional follow-up searches to the users if they want to go explore that topic further. Obviously, and not surprisingly, for queries that do require world information, a huge improvement in terms of the rate of hallucinations when you're providing the model with that relevant information. So obviously, that kind of step increase in quality is something that drives a lot of usage in this. I'll circle back briefly here to something we talked about earlier, which is how a lot of the agentic reasoning is being kind of shifted upstream increasingly to the models themselves. And so one of the things that's happening at this point is when a user query comes in, we're able to now perform multiple searches for that same query in parallel. So you see the example here asking about two leading lights of the football world there, Messi and Ronaldo. The reasoning part of Gemini is able to understand, there's multiple searches to be done here. Let me run those in parallel, and then in the response, we're able to leverage information across those searches. So here we call this query fan out. The other part of this, which came with 2.5 Pro in the Gemini family, is not just running multiple searches, but doing them sequentially. And so we talked earlier on about that reasoning step of thinking through both what the plan is to retrieve information, but also what additional searches to perform. So here we're asking around an Olympics event. We perform one set of searches. We think about the results we've gotten back, and then perform a secondary set of searches as well. And at that point, the model is able to create an answer on it. So again, very, very cool to see a lot of this agentic reasoning being moved upstream to the models themselves. A lot of different, very, very kind of use cases for this kind of technology. A lot of these are kind of consumer oriented use cases. I'll also highlight Google Maps, and so this is one that literally just shipped to preview a few weeks ago. Really excited. This is a great collaboration between Google Cloud and our Maps team. So obviously with Maps, an incredibly rich source of information, 250 million places worldwide. So incredibly rich, very helpful. And a lot of this came from desire and feedback we heard from the user community that we actually want to offer use cases and applications that help users discover very local, very fresh information around them. And so now you're seeing this ability to connect, in our case, the Gemini model family with Maps, and be able to really unlock a totally new set of experiences. So you see the example on the right, you're walking around, what are my fitness options around me? And be able to use Google Maps to go find what are the relevant fitness locations, as well as some potentially rich information about those. So a lot of this is using Maps to, again, provide much more powerful, much more fresh, geospatially kind of relevant context to users. And so you see another example here, cocktail bar located close to my hotel. So again, this integration between Gemini and Maps, we can understand where your hotel is, the different options around this neighborhood, and actually potentially recommend a few. One of the key things about using a tool like Google Maps is, again, the freshness of the information. So without Google Maps, you're potentially sending users to restaurants that are closed. We don't have their most updated hours, may not even be in the right neighborhood. And so Maps is actually addressing a lot of those pain points that we've heard from the developer community that, hey, if I'm going to provide an answer to my user, I want to have very high levels of confidence that this is something that's actually open right now. The other fun thing about this now is we've added place information into this. And so being able to leverage the power of Google reviews, of Maps reviews. And so you can start asking natural questions about a place. For example, is this a family-friendly place? Can I bring my kids there? Or what's the vibe, as it were? You know, you see this speakeasy example there on the right. And so you can ask those, users can ask those kind of natural questions, and we're able to leverage, again, the power of those reviews and provide much more, hopefully, helpful, kind of insightful answers to users there. Nearby recommendations. So again, if you just want to ask generally what's around me, we can bring back details around, you know, distance, the ratings of a potential place, accessibility information, all of that as well. And then as you start thinking about the use cases of a tool like this, being really able to personalize and customize the kind of content that you're providing to users. And so this is an example. You can see there, you know, kind of a real estate example. So if you have signals about a user that, for example, they have pets or they have kids, being able to customize the presentation of a neighborhood or a specific listing based on those needs. And so again, does it appeal to dog owners or families with kids? All that. And then we're seeing kind of applications emerge across a number of different verticals. I'd say travel and tourism and real estate are probably two where we're seeing a lot of excitement and adoption. So again, helping travelers discover interesting places to eat and locations to visit around them. On the real estate side, being able to learn more about neighborhoods and specific listings. On the social media side, a lot of this is helping kind of groups of friends and communities plan locally based, you know, activities. And then even on the devices side, so being able to power some of this with on-device kind of use cases. All right, so that was kind of a whirlwind. So we talked about grounding your information on your enterprise data and some of the developer tools we provide there. We talked about grounding on Google search for the kind of world's fresh, relevant information. And then, yeah, the latest part of the offering, which is grounding with Google Maps. And so being able to leverage a lot of those kind of very fresh, you know, geographically relevant use cases as well. I've included a couple links here. I think we'll be able to, hopefully, I can try and post them into the chat room as well. Just a couple links, one to vector search if you want to get started with that, and then our grounding solutions as well. So I think that's all the slide and content where I had prepared. It looks like a couple questions came in. Awesome. So I will pivot over to taking a look at those. Okay. So give me a second to scroll through some of these.
I just added them to the end of the chat for you.
Oh, great. Okay. Oh, perfect. Cool. So a question about demos to assess value quickly and interoperability across dynamic environments. Really great question. And this is actually honestly a place where we've been investing more and more. For demos on the developer platform side, we've actually got some really nice demos using real world data sets. So we partnered with one of our partners out in Japan to leverage and to create and leverage their e-commerce data set. I'll see if I can add a link to the chat, but you're able to start experimenting with some of the search features that the developer platform provides, you know, both hybrid search, keyword search, and get a sense of whether this is the kind of search capabilities that are helpful for a use case like yours. Interoperability across dynamic environments. Yeah, and I think you know, a lot of this is intended to scale across the kinds of data that I think you're talking about. So, you know, when I think about, you know, dynamic environments, it's new data coming into the corpus, so being able to generate fresh embeddings for them. Obviously, user queries coming in. So a lot of this is designed to be able to scale hopefully relatively easily. As you saw with our 2.0 vector search launch, a lot of this is intended also to make scaling that much easier. So you're able to, if you want to, automatically scale the solution, create embeddings natively, hopefully taking a lot of the pain out of having to manage the solution. The sparse embedding that I showed, so a question just about sparse embeddings. So one of the great features that we offer now with vector search is the ability to offer both dense and sparse embeddings. Again, historically, a lot of our partners, developer partners out there, were maintaining these kind of parallel search systems, and so now you can use both dense and sparse embeddings, and hopefully make life much easier. A big part of this is obviously being able to work with unstructured data. So a question came in around our support for unstructured data. A lot of the solution is actually designed just for that. So you've got your PDFs, slides, images, all of that. How do you actually make that relevant and searchable to your agents, to your applications? And again, with that pipeline of being able to chunk the data, in our case, using a tool like our Doc AI layout parser, creating embeddings. Obviously, we offer our own, but you can bring your own embeddings models if you prefer, and then be able to index and serve those embeddings through vector search, and then potentially re-rank them. All of that is really, historically optimized and intended to work with unstructured data. So certainly able to support that. And then just looking at a question around agents, does it natively support real-time? Oh, okay. A question around real-time data retrieval from live enterprise sources, or are these systems currently designed to work primarily with pre-indexed vector databases? So a great question, I guess, really goes to the dynamic nature of a lot of these enterprise sources. The intention now is to make these very real time, and so if you're dealing with an e-commerce system, again, that has needs to look at not just matching user queries to particular results, but also being able to have an understanding of availability of those results. I think a lot of what you're seeing with 2.0 and the ability to maintain not just the embeddings, but all the metadata around them, you're able to make this a much more relevant, live, dynamic kind of solution. And so hopefully, that makes it easier to support the kind of dynamism that I think one of the questions here is describing. So really great question. Question on the BigQuery connector. So BigQuery data, how do we integrate that with vector search? So the nice thing here is that, for those customers that have made pretty deep commitments to using BigQuery, BigQuery offers, I think, its own native vector search tool as part of it. But we heard from a lot of the community that they also want to be able to leverage, the scale and performance that a purpose-built tool like Vertex Vector Search offers. So a lot of the motivation there was, can we offer the best of both worlds? You get to keep your original data in BigQuery, but leverage vector search. And so we've got a connector that basically automatically creates embeddings and copies them over to vector search. So you're able to automatically copy over the embeddings and maintain those, as an updated connection, and then use vector search to be able to run the search on top of the embeddings that have been brought over. So again, you get to keep all your data in BigQuery, and then we'll automatically copy over embeddings to vector search there. Question on the Google Maps integration. So are these coming, are the responses, are they coming from the reviews, SEO? So just thinking through how to streamline the response. So at this point, the information that we're getting back from Maps includes both some of the more structured information we have about a location. So let's imagine like the hours that it's there, or the type of cuisine, for example, if it's a restaurant, the ratings, the location. So we get all of that. And then we're able to leverage the user reviews as well. it's not that the user reviews are directly made available in the response, but the response is based on those reviews. So, for example, if someone asks, "Is this restaurant kid friendly?" Gemini is able to go look through the reviews and see which parts of it are answering that query about kid friendliness, and then bring the response back. So the user reviews are being leveraged, but they're not directly provided in the response. Question about the on-prem world, and so kind of nature of data that's particularly sensitive. So thinking about cloud as well, but there's concerns around data sensitivity and leaving that data. How do we think about addressing this? Yes, this actually question does come up, and we've worked with a number of providers out there that have some form of on-prem requirements. And so I think there's a couple different levels of thinking about this. One is trying to shift, obviously, towards a full cloud solution based on the investments that Vertex and others have obviously made to secure data. But again, assuming that the on-prem part is a hard requirement, the next kind of option down is to think about, well, can we just bring the embeddings to the in-cloud? And so you think about a hybrid solution of keeping the raw data on-prem, on-site, and generating the embeddings potentially there, but then just porting over the embeddings to the cloud, and potentially there's less risk or less sensitivity just on the embedding side. And that's actually a solution that we've seen work not just in hybrid, on-prem and cloud environments, but actually across cloud providers. So we've worked with customers who've made an investment to manage and store their data in one of the other cloud providers, but want to use some of our developer platform tools. What they can do at that point is leave the data where it is and just bring the embeddings over to us. And so again, that's another flavor of the hybrid world. So to answer, yes, I think the raw data can stay where it is. Think about bringing the embeddings to the cloud itself. And then an interesting question here about a different domain, the social science domain. So methodologies for understanding if data is relevant. So there's situations where a query can have multiple different meanings, and how do you actually understand user queries? Yeah, I think our semantic search technology that you're seeing with the kind of pipeline that we described here really is intended to be able to hopefully understand the potential meanings behind a user query and surface relevant information. And I guess there's kind of two parts of this to highlight. So one is the query kind of rewriting and transformation step. So again, within Gemini and then now within the developer platform itself, there is this step there where the tools themselves are trying to expand upon the user's query and make sure it's optimized for the search piece of this, for the retrieval piece of this. So that's one. And then the second piece of this is, just depending on the embeddings model, a pretty deep, semantically rich understanding of both the user's query as well as the underlying data that's available, and be able to retrieve that data accordingly and generate an answer. So I definitely think if you've got a use case with a lot of that nuance, hopefully you'd be able to see some pretty solid results using technology like this. Okay, I think that was all the questions and just about on time.
Someone asked if you could post your GitHub. They don't have LinkedIn. Do you have GitHub you can share?
Yes, I will grab it.
Thank you, Greg, for your wonderful session on grounding. I hope everybody enjoyed it. And thank you all for joining us today. I would not take much time, but yes, please fill the survey. QR code is mentioned on the screen. Please fill the survey and let us know, how did you find this? Any improvement or feedback you would like to give? I can see so many emojis on the screen. Guys, show your excitement that yes, or show us how did you find it just by your emojis as well. So Greg, people enjoyed it.
A huge thank you. Thank you to the community for having me. I hope you'll have me back again. We've got a lot more updates approaching. Thank you to Nisha and Aziza for helping organize.
And thank you for your time.
Absolutely. Thank you, Greg, for a great presentation as usual.
Guys, do fill this survey and let us know how did you find it.
There was one quick question about Vertex AI and how it handles data privacy encryption. Are you able to answer that quick question? It came in at 9:58.
Yes, I see that. So how does Vertex AI handle data privacy encryption, access enterprise data? Yeah, I'll actually, I think one of the big pushes has been that kind of enterprise readiness, which I think is what this question is getting after. So it does provide all of that. Let me actually just add that directly into the chat itself. I've got a couple go-to links if you want to read up more about that. But yes, we definitely support those kind of enterprise readiness features.
So is there any other question?
The link that you posted, is that from GitHub? Someone requested your GitHub.
Yeah, I could go track down my GitHub. I just was posting a link there to customer managed encryption keys there. So I think that was part of the question that came in about the enterprise readiness. Let me see what else I can grab here. And I will follow up to get my GitHub link as well.
Perfect. You can always share your GitHub in the follow-up email. So thank you everyone for being here for this amazing informative call. And thank you so much, Greg and Nisha, for your support and assistance.
And thank you too for your wonderful support over chat. All right.